Hi, this is Unit 5, Chapter 1, Lesson 7, and Mr. Romanovich is going to be talking about constant rate of change. Here he is.
Hey, so yes, I did purposely choose the black sweater so that it would look like my head is floating. And yes, I am holding onto the board because the boards are very ready to fall. So please do not let that distract you. Here we go, constant rate of change. By the end of this, you should be able to use tables and graphs to find the constant rate of change. What is the constant rate of change? We'll talk about that in slide 2. But by the end of this, you should be able to find the constant rate of change of this table and the constant rate of change of the graph that I provide at the end, not this graph. Do not try to graph that. So let's move this dangerously forward and get to this. What is the constant rate of change? So constant rate of change is how one quantity changes in relation to another. So as we see in this table here, we see cars washed and cost. So that would end up being what we take in. So here if we wash 50 cars, we take in $1,000. If we wash 100 cars, it's $2,000, so on and so forth. And what we start to look at is we start to look at how these things change. So 50 becomes 100 by adding 50. 100 becomes 150 by adding 50. 150 becomes 200 by adding 50. Similarly, on the bottom, we have 1,000 becomes 2,000 by adding 1,000. 2,000 becomes 3,000 by adding 1,000. And 3,000 becomes 4,000 by adding 1,000. That does say 1,000. So this is all data that we're going to be describing also as, just sort of keep this in the back of your mind at this point. This is something that will come up in the next couple lessons. But what we're seeing in tables is whatever is listed first is our x, and whatever is listed second is our y. And I always think of this in terms of how the alphabet works. X always comes before y. So as you see this listed here, it is always x and then y in everything, in tables and in graphs. So for this, what we always want to find though when we're looking for constant rate of change is the change of y over the change of x. So in this case, our change of y is the cost, and that change of y is $1,000 is 1,000, 1,000, 1,000, 1,000. That becomes our numerator. Then our change of x, then our change of x is the change in the cars for this table. 50, 50, 50. So that's 50 cars. And what we then have to find is we have to find the unit rate. And we do that by just dividing this and keeping our units. So and this would end up being $20 per car. 1,000 divided by 50 is 20. $20 per car is our constant rate of change for that one. Okay, here we go. Transition. Here is a second table. Now the table's listed vertically. And in this table vertically, what we're seeing is the same thing. We're going to see that x comes before y. And as we look at the data, and this would be cars. As we look at the data, we're going to look at the change. 5 becomes 10, that's plus 5. 10 becomes 15, that's plus 5. 15 becomes 20, that's plus 5. 40 becomes 80, that's plus 40. 80 becomes 120, that's plus 40. Are you seeing a pattern? 160 plus, or 120 plus 120 plus 40 is 160. So now we always want to put our change of y over our change of x. X then y in the alphabet, but then as we show them, we're going to show our y's over our x's. Our change in y here is $40. Our change in x is 5 cars. Then we find our unit rate by dividing the two, and you've already done that in your head, and that becomes $8 per car. So that's our constant rate of change, $8 per car. Now let's get to our big board. So here we are now with graphs. So what I've got here is a graph that describes time in hours versus distance in miles. Critical in remembering this is that this is your x-axis, this is your y-axis, so these are your x's, these are your y's. So now we look at this, and all we're going to do is take 2 points. Any 2 points along this line, and if we subtract one from the other, we will end up with the data that we need. For instance, we're at 0, 0, and here this point is 160. This point here would be 2, 120. This point here is 3, 180. X then y, x then y, x then y. And this forms a straight line. Please bear with me with my straightness. And that line goes on forever, so it gets an arrow point. And then if we choose any 2 points of this line, if we subtract one from the other, x to x, y to y, we will get our rate, our constant rate of change. So in here, we want to put miles on top, because that's our y over x, change of y over change of x. I've chosen the first point, 0, 0, and the second point, 160. So if I have 60 minus 0, 60 is my y, 0 is my y. 60 minus 0 is 60 miles. 1 is my x, and 0 is my other x, 1 and x. That leaves me with 1, 60 miles over 1 hour. So I know the constant rate here is 60 miles per hour. But if you also have to determine this, what is the value of the point 160? What does that mean? Well, what it means is, on the x side, 1 being the x, it means we've traveled 1 hour. And on the y side, the 60 indicates, I check my thing here, the distance we traveled. In 1 hour, we traveled 60 miles. So here we go. Can you do this? There are 2 of these, so get ready. Can you find the rate of change in this? There we go. Here's our table. We have time versus distance. So you'll find the rate of change in each of these. Then you'll find the rate of change in each of these. And then you'll know which one to put on top. I put it on there. Y's go over x's. X then y. Find the change, and then figure out the unit rate. This is a 120. And now we have a graph. So important in the graph for you to see is the points that I put on here. That'll be the easiest way for you to tell. These are the 3 points that I've placed on the graph. You need to find the change of y over the change of x. You have to know which one of these in each of these coordinates is the x and the y. Pick one of each, subtract, then find your unit rate after you do that. If you have any other questions, you can ask Mrs. Benoit, or you can ask me, or you can rewatch this video, or you can look at your book. Otherwise, good luck.